This is 1.5, number 12 from the Math 126 open enrollment class. And graphing these can be a little interesting. There's a couple ways to go about it. One is you can just think about your original function like g of x equals the square root of x. And know that's going to start here at 0, 0, go through 1, 1, go through 4, 2. And those are the nice points to come across for this. On this graph that goes up to 9 for x. And then you think about what's happening to it. So you got the plus 1, so it shifts it up by 1. In fact, before I do that, let's talk about this negative 3. So the negative 3, the negative is going to make it reflect below the x-axis, as we see here with this one. And this negative 1 is going to shift it to the it helps rewrite this. Think of this as negative 3 times the square root of negative of x plus 1. So the plus 1 with the x before anything else is applied, that shifts it to the left by 1. Okay? And then we have this negative here is going to flip it across the x-axis then. So start putting this together, and then the 3 is going to stretch it vertically. What I found more helpful on that, because I feel like there's just so much going on with that, is to look at this function, this negative 3 times the square root of negative x minus 1 plus 1, and put some values in here. I mean, it may be helpful to start with, say, negative x minus 1 equals 0 when negative x equals 1 or x equals negative 1. So that gives us a place to start things. And then think about, we were under a radical, so let's look for perfect squares. And what if we went with negative 5. So negative 5 minus, no, let's not do negative 5. Let me, the negative of negative 5, that's what I want. Minus 1, so it's 5 minus 1, which is 4. So we're looking at the square root of 4 is 2. So we have negative 3 times 2 plus 1. Negative 3 times 2 is negative 6. Negative 6 plus 1 is negative 5. So negative 5 will be going through negative 5. And let's think about the value. What if we went with the value, something that'll produce from the radical the 1. So if we went with x equals negative 2, then we have negative 3 times the square root of negative 2 minus 1 plus 1. That's negative 3 times the square root of 2 minus 1 plus 1. So negative 3 times the square root of 1 plus 1 is just going to be negative 3 plus 1, which is negative 2. Oh, I got that in the wrong spot. I apologize. Should go here. So we're getting a curve that looks like this. So let's go over to the program and try to do this. So what do we have? We had it at negative 1 was, well, negative 1 plus 1. Wasn't that negative 1 going to be a positive 1? I need a curve like that. Okay. So and then the negative 2 was here. Negative 5 was at negative 5. There we go. it looks like the curve. So let's just check that. Yeah. Now this one stops here. It doesn't show going up, but if I go back to here, when I put -1 there, let me rework this. For x being -1, -3 times the square root of -1 minus 1 plus 1. It's -3 times the square root of, it's 1 minus 1 plus 1. So -3 times the square root of 0 plus 1 is 1. So that should go up to the 1 up here. And I believe that's how the best way to get that answer. Okay. So I will say one thing about this. Just this curve doesn't really show a starting point on a solid cross, a solid point. My belief is it's up here, but the graph doesn't show it. And I give a lot of grace on these, so if you got close, you didn't get points, let me know, and I'll give you credit there, because just these can be rather complicated. But I do want to point out that this does go through that -2, just like this one, and -5, -5. Now a question came up about number 19. It looks like this person got it correct, but just to address what's going on here, again, think of this as the square root of the negative of x plus 5 minus 4. So because it's x plus 5, you can think of it as x minus -5. So it's going to the right -5 or going to the left by 5. So that's left 5. And then this negative here reflects it across the x or across the y-axis. So if you get to the rest of this, what is the basic function? It's this one here. It's the square root of x. And reflect across the y-axis as discussed because of this negative here. And then shifting left by 5. We talked about that. And then this -4 makes it go down by 4 units. And then to find the graph then, if we look through this set, it's already been checked off, but something that would have started like this. It's being reflected and then shifted down. So this one is reflected and shifted down. That's it. Hope that helps.